Let's talk about epithelial tissue. So epithelial tissue are sheets of cells that line your inner and outer body surfaces. We have some cavities. The pericardium is a sac around the heart. The peritoneal is a sac around the lungs. So we're going to start lining your sacs, your body cavities, your blood vessels, your digestive, your respiratory. Epithelial is this sheets of cells doing that protective thing and allowing stuff to move in all these different areas of your body. So we just have epithelial literally from the inside out. Now, when we start talking about epithelial tissue, you're going to start talking about how do we classify them? And we classify epithelial a couple different ways. So that's mainly what I want to talk about today. So let's talk about classification. We look at two major things. How many layers do we have? And what is the shape of the cells? So when you look at a microscope, and I send you those virtual pictures coming up here, if it's epithelial, I'm looking for how many layers am I dealing with and what is the shape of those cells, okay? So the first part is pretty simple. Number of layers. Do I have one layer? Do I have multiple layers? For whatever reason, epithelial does not come in groups of layers of two. I don't know why. It's either one or multiple, okay? So simple is one layer. You got just one layer of cells. Stratified is three or more. We skip two. And pseudo is, pseudo means false. So pseudo looks like it's two, but really it's this one. Okay. So when you look at epithelial tissue, you're looking at, am I dealing with one layer or am I dealing with multiple layers, as you see over here on the side? So you can see stratified has got lots of layers, and then simple has one. And when you see slides, and you'll see this when we do our virtual lab, it'll say simple squamous, simple cuboidal, simple columnar, stratified columnar. And that's what we mean by that first word. It just simply means three or more layers of cells, okay? The really odd one is pseudo, because pseudo gives you a false look to it. And we'll talk about that, especially in the bladder. You see that a lot, okay? So that's all that means, pretty simple. One layer, three layers, or a fake looks like two, but really is more than that. That's the only choices you got, okay? The shape is where you really identify an epithelial slide, an epithelial tissue. So if you look at squamous, they look like flat pancake-like cells. Literally, they're just pancaked. That you see that right here. Looks like someone ran over them with a truck, okay, a dump truck. So very flat. Going to find it in places where I need to move things through it really fast. And we've had a lot of squamous in our skin, which we'll talk about later, okay? Columnar are tall, skinny. They're taller than they are wide. They look like those big columns you see on those big Greek cathedrals and things like that, or the White House pillars if you've been to Washington, D.C. That's these guys, okay? So you can see tall and skinny, okay? And then we have cuboidal. Cuboidal look like ice cubes. The only best way to describe them. Look like little cubes. You can see them here. And we're going to look at these under the microscope, and you'll see what I'm talking about. So you're looking for flat, tall, skinny, or cubes, okay? And then we got the odd one, okay, is transitional. That's where the shape of cells vary. Think of your bladder. If your bladder is full, they're going to be pancaked. They're going to be squamous. If your bladder is empty, they kind of bounce back and they look like cuboidal. So it's going to go, depending on the condition of your bladder, they're either going to be cuboidal or squamous. It just depends on what look they have, okay, and what condition you're in. You got to go to the bathroom or not. And that sounds funny to say, but that's pretty much what it is, okay? So that's basically what we're looking at. So we're going to circle back to that, and I'm going to show you some real pictures of them eventually, and I will, I can show you a few right now. So when we look at them under the microscope, it'll make more sense to you, I think, anyway. So here we go. Here's what were real pictures. You can see some squamous at the top, more cubes at the bottom. These are cuboidal ones. This is your bladder where this is empty. And then when it's full, it smashes them out pretty much. Here's a better view of it. It's kind of labeled. This is actually, here's your cuboidal. If I kind of outlined them here. Now, if that fills, then that's going to turn into a pancake-like one. Okay. Here's some columnars. You can see tall and skinny. Okay. You can really see it on these two. These are columnar cells. All right. If you outline them, you can see what I'm talking about. Really tall and skinny cells. Okay. So that's kind of what you're looking at with those guys. Not hard. Epithelial is pretty easy because we're just looking at what's the shape of the cell, and do I have one layer, or do I got 3 or more layers? Basically what we're looking at with those guys. All right. Couple more things. Kind of a long video today, but I want to kind of get you ahead a little bit so that I'm going to go over this stuff today with my class at school. So this will get us caught up for our weekend coming up here. So some facts about epithelial, and I'll just kind of hit some of the basics here today. What does epithelial do for us besides protect us? We get it. There's some other things. Epithelial has some small spaces that have fluid in it, kind of gives a little give to it. So when you push on your skin, it obviously bounces back, right? And what we like to really pay attention to is this basement membrane. So your epithelial is glued to the connective tissue underneath, and that's what holds your skin in place. You probably heard of the disease leprosy, where the skin pulls off back in the biblical days. That's basically what the basement membrane doesn't hold. So think of Elmer's glue, and I'll talk more about how we kind of lay down a bead of glue when we glue papers together. That would be the basement membrane. Okay. Epithelial is avascular, which means there's no blood vessels. Now I know you say, well, wait a minute, if I cut my skin, it bleeds. That's actually the blood oozing up from below. It's actually down below the epithelial, and it moves through and it bleeds, but it's actually technically avascular, means with no blood vessels. Okay. And then how do we attach epithelial? There's a couple different ways. So I'm going to use a little kindergarten example. All right. A desmosome, I'll show you a picture of that, is a disc of adhesive material. When you weld, I weld stuff. So when you weld metal together, a lot of times you'll just do something we call tacking, where we weld here and we move down, weld a little spot, and then we come back and weld it completely together. We basically do that to hold it in place. So that's what a desmosome is. It's these thin disc of adhesive material. That's what I meant by spot weld. And you can see it here. So I don't have any here. It's glued here. That's a desmosome, and on down here. So in places where you can see them here, they're kind of spaced out. In places where I don't need much strength, places where there's not a lot of movement, like where capillaries maybe are at, or things like that, desmosomes work. It's just the body's way of conserving things. So I don't need a bead of glue. Think back to kindergarten days. Well, you go back to that. Back in kindergarten, teacher would say, hey, we're going to glue 2 pieces of paper together, right? And there's 2 ways we can do that. We can just put a big bead of glue and smash that together, or we can just put little dots every so often and put it together. Obviously, the dots hold, but wouldn't hold as good if I put a whole bead of glue across something. So that's the difference between these two. A desmosome is just those little dots of glue. And we go back up in notes here. Whereas a tight junction, or tight joint, we call it, that is where we're going to put a bead of glue all the way across and fuse basically the tissues together. A lot tighter of a fit. Going to be places where we got lots of movement, like arteries and veins and things like that. So going back to that slide, and I apologize because, again, I can't do the links. That's what we're talking about down here. See, you don't see any space. You see space up here on either side of a desmosome. When you get to a tight junction, you're not going to see any of that space. Okay. So that's the only difference between those two. Don't get confused with that. It just means, am I using dots of glue, or am I using a bead of glue? Okay. Last thing with epithelial, we got mitosis. That's where cells, we know that from Bio 1, where they rapidly reproduce and produce more. That's what we worry about with burn victims. Do we burn past that layer where mitosis is going on? Epithelial dies and we replace. So mitosis is a critical part to that. Okay. Last thing is these. Sometimes we take columnar cells and we modify them. Okay, goblet cells look like maybe you've seen medieval pictures where they have those little skinny, or like an Erlenmeyer flask in chemistry, skinny top, round bottoms. I've been to medieval times in Florida. I don't know if you've ever been there, but where you actually drink out of these goblets. So that's back in the medieval days. We have those in the body, and that's what they look like. And they secrete mucus. Now, it sounds kind of gross, but when you got cold and allergies, like I do right now, that's where that mucus comes from. It helps move infectious material out of our body. Cilia are tiny little hairs that beat back and forth and move inhaled particles out of the lungs. They help move the ova in the female, the fallopian tubes into the uterus. And then microvilli are little fingers that are thicker than cilia, and they kind of increase surface area in your intestine. These are just columnar cells, tall, skinny cells that the body has taken and modified them to do a specific task. All right. See if I can find these for you on my slides here. Nothing more, nothing less. They're just specialized. Here we go. So there are these columnar cells that we've taken, and hang on a minute. Let me pause this till I announce this. Sorry about that. We're going to get some. We're going to get some schools getting ready to start, so you guys know how it is. So you can see this is microvilli down here. We just modified them. These are goblet cells. See the round bottoms to them. It's just things that we've taken and we modified to do a specific task. All right. So that's pretty much epithelial tissue. We'll talk a little bit more about those when we do our little virtual lab. But hopefully that makes sense. Again, guys, don't forget we have Google Meets. Please show up for those Google Meets, not just for your attendance, but so I can touch base with you and make sure you don't have questions. Most of you did okay on the test. That's kind of how we're going to do tests. Worked out pretty well, and thank you for cooperating on that. So if you got questions, shoot me an email. Ask me during our little Google Meet on Friday. Same time, same place, like we've done about 12:23 or so. We'll get on tomorrow and see if you got questions. So, hey, we'll see you tomorrow, and have a great Labor Day weekend coming up here if I forget to tell you tomorrow. So, hey, thanks for checking in. We'll see you. Bye.